Right, in this video I'm going to run through the questions here for quiz 12. We've got some questions here from CC9, some moles tables, and we've also got some of the stuff that we have been doing this year on alkanes and alkenes. First question is a calculation question. Straightforward one, as long as you know your G Mr. Moles triangle. You are given the number of moles. You are given, oh no wait, sorry, ignore that. You are given the mass of magnesium, 0.1 grams, and you're asked to calculate the number of moles of magnesium. So using my G Mr. Moles triangle, if I cover moles, I'm left with G divided by Mr. So moles equals G over Mr. The G is 0.1 grams, so I fill that in. And then the Mr is just the formula mass of magnesium, when magnesium is just by itself, and that's given to you here as 24. So it's going to be 0.1 divided by 24, and you can give your answer in standard form or write it out as a decimal, 0.0042. In the next part, they say in a further experiment, 0.5 moles of hydrochloric acid was mixed with 0.5 moles of magnesium. And they want you to show that magnesium is in excess. That word excess just means that you have got more magnesium than you actually need. And if you come back here and look at the equation, you can see that the ratio between magnesium and hydrochloric acid is 1:2. Okay, so they're telling you that you're after adding 0.5 moles of hydrochloric acid. Okay, so I've added 0.5 moles of hydrochloric acid, and using my ratio, right, which is 2:1 going this way, that means I would only need 0.25 moles of magnesium to have a complete reaction. Okay, because of that ratio, if you've got 0.5 of HCl, you only need 0.25 of magnesium. But they're telling you that instead of having 0.25 of magnesium, you've actually got 0.5. You've got way more than you need, but that's what you're asked to explain. How do I know magnesium's in excess? How do I know I've got more than I need? So I've written here the ratio is 2:1. So if you had 0.5 moles of HCl, you would only need 0.25 moles of magnesium. You've actually got 0.5. You've got more magnesium than you need, and that's just another one marker. The next one down here is your classic moles table, which I have started for you. So don't be put off by this whole dot H2O. It doesn't make a pick of difference, okay? You're told that you're heating this gently until all of the water has removed, and this is the equation that we're looking at. And anytime we're doing a moles table, you need to see what you've got information about and what you're being asked about. So the first number I'm given here is the mass of water, okay? That means water needs to go in my table, and I write the formula of water, H2O, exactly as it is in my equation. Calculate the mass of the hydrated copper sulfate. Okay, so you're being asked about the hydrated copper sulfate. You're going to need to figure out which one of these is hydrated copper sulfate. Well, hydrated means it's got water, so I'm going to go for the copper sulfate that has the water attached. And I'm going to write that into my table exactly as it is in my equation. So they're the two things that should go in my table. I write down my G Mr. Moles and ratio. Mass of water is 4.5, so I fill that in. Formula mass I'm able to work out. Okay, so H2O has got two H's, that's 1 plus 1, and 1 oxygen is 16. 1 plus 1 plus 16 is 18, so that's my formula mass of H2O. The formula mass of this one, thankfully they've worked out for us already, 249.5, so I can fill all that in. And then the last thing I can fill in is my ratio, and if I go and look at my equation, there's nothing in front of the hydrated copper sulfate, so I write a 1, but there's a big 5 in front of H2O, so I write down a 5. Now I can fill in the rest of my table. So the first thing I can do is I can work out moles, G Mr. So I do G divided by Mr. to work out moles. And if I do that, I get an answer of 0.25. Then I need to use my ratio. Okay, we can see that this number over here on the left is 5 times smaller than the number on the right. So to make this number 5 times smaller, I'm going to be dividing by 5. And when I do that, I get 0.25 divided by 5 is 0.05. And once I know moles, then all I'm doing is timesing these two numbers together. 0.05 times 249.5 equals 12.475. 5. Okay, and you're not asked for a particular number of significant figures, so I can leave that as 12.475, and that is going to be my answer. Next page is a similar type of question. Okay, again, I'm given an equation. And this time I'm told I'm starting with 1.35 grams of magnesium. So I'm given information about magnesium. So I'm going to go to my equation and find which one is magnesium, which is this one here, Mg, and I'm going to put it in my table. Then I'm asked to calculate the mass of magnesium oxide. So I need to go to my equation and find magnesium oxide, which is this. MgO is magnesium oxide. And again, I put that in my table. So you have to have two things in your table that perfectly match what's in your equation. Okay, you can't change these formula. So I've got magnesium oxide, and it says the mass of magnesium is 1.35, so I can fill that in. The Mr. I'm going to have to work out using these numbers down here. So when magnesium is by itself, it's just 24, but magnesium oxide is the 24 for the magnesium plus the 16 for the oxygen, gives me a formula mass of 40. The ratio I get from my balanced equation, so there's a big 2 in front of the magnesium and there's a big 2 in front of the magnesium oxide, but a ratio of 2:2 can be simplified to 1:1. Alright, so now I just need to work this out. So I'm going to do 1.35 divided by my formula mass divided by 24, and I get 0.0565, and I wouldn't round that. I would write that whole thing in without rounding it. I'm not going to round until the very end. My ratio is 1:1, which means the number of moles over here is exactly the same. And then to work out the mass, it's moles times Mr. So I'm timesing that by 40, and I'm getting an answer of 2.25 grams. And again, I'm checking I'm not asked for a particular number of significant figures. Next one, similar story. Okay, I've got zinc and I've got copper sulfate, and I'm told the number of moles of copper sulfate. So because I'm giving information about copper sulfate, I'm going to go to my equation, I'm going to find copper sulfate, and I'm going to write that into my table. I'm then asked about zinc, the minimum mass of zinc, so I'm asked about zinc. So again, I go to my table, I find zinc. Now it's not zinc sulfate, it just says zinc, so I want Zn by itself, so I put zinc into my table. I write down my G Mr. moles, and this time instead of giving me the mass of copper and asking me to work out the moles, they've just given me the moles straight away, so I can fill in the moles of copper sulfate straight away. My ratio between zinc and copper sulfate is 1:1. That must mean I've got 0.043 moles of zinc. I know the formula mass of zinc is 65, so I times 0.043 times by 65, and I end up getting 65 times 0.043, and I get an answer of 2.795. Now this time we are asked to calculate an answer to one decimal place, so on the answer line I'm going to write 2.8. I'm going to round that up. The next one over here, question 16. Okay, calculate the number of moles in 45,000 grams. If you're asked for moles using my G Mr. moles equation, moles is G divided by Mr. The G they tell me is 45,000. The Mr you're going to have to work out. Now you're being asked about titanium chloride. Titanium chloride is TiCl4. So to work out the Mr, you've got one titanium, which they tell you has a mass of 48, but you've got 4 chlorines, and each chlorine is 35.5. It's going to be 35.5 times 4. 4 chlorines, 1 titanium, add them all together, you're going to get 190. And once you know your formula mass, it's 45,000 divided by 190, and that's 236.8. Again, it doesn't specify number of significant figures. The next one, they want to show you that 500 moles of magnesium is an excess. Remember, excess means you've got too much, more than you need. So if I go back up here and I look at my ratio, I can see my ratio between titanium chloride and magnesium is 1:2. All right, that means I need double the amount of magnesium. So if I've got 236.8 moles of titanium chloride, okay, if I multiply that by 2, I'll work out how many moles of magnesium that I need. 473.6. So this is the number of moles of magnesium that I need, but they're telling you that you've got 500 in there. You can see that 500 is more than you need, so I'm showing that magnesium is in excess. There's too much of it. The next one's a bit different. The next one, again, if you're given this number, you have to use it. We're going to be using Avogadro's constant. And if I want to use Avogadro's constant, I always need to work out moles. So to work out moles, it's going to be mass divided by formula mass. I'm going to work out the formula mass with you here. So aluminium sulfate. Right, so in aluminium sulfate, you've got Al2. That means you've got 2 aluminiums. Aluminium is 27, so it's going to be 27 plus 27. All right, the next element you get to is sulfur. You've got 3 sulfurs because sulfur is inside the bracket and there's a 3 outside the bracket. So I've got 3 sulfurs. Sulfur is a mass of 32. And there are 3 of them, so it's 32, 32, and 32. We can just write 32 times 3, all right? And then I get to oxygen. Now, there are 4 oxygens inside the bracket, but there's a 3 outside the bracket. And just like in maths, brackets mean multiply. So I have to do 4 times 3 is 12. I've got 12 oxygens. Each oxygen has a mass of 16, so it's going to be 12 times 16, and then I add all of that up. And I'm going to end up getting... I'm going to add this all up. 12 times 16, I've got a mass of 192 just for the oxygens, and then I add on the 54 for the 2 aluminiums, and then I add on the 96 for all of the sulfurs, and I end up with a formula mass of 342. Alright, so there's a bit of work there working out the formula mass. But once I know mass and formula mass, I can work out moles. So I do 5.13 divided by 342, and I get an answer of 0.015. Now that's the number of moles. Now you're asked the total number of atoms. So once I know moles, moles, I need to times moles by Avogadro's constant. So it's always moles times Avogadro's constant. And when I do that, I get 0.015 times Avogadro's constant equals 9.03 by 10 to the 21. Now this number here, this tells you how many aluminium sulfates you've got. Okay, so if this number was 2, you would have 2 aluminium sulfates. It was 10, you would have 10 aluminium sulfates. But you've got this huge number of aluminium sulfates. But you're being asked how many atoms do you have in total. Okay, you have to look at aluminium sulfate and see how many atoms each aluminium sulfate has. Okay, so we can see there's Al2, so you've got 2 aluminiums, you've got sulfur times 3, so 3 sulfurs, and you've got oxygen times 12. You've got 12 oxygens. So when I add that up, I can see I've got 17 atoms. So in each aluminium sulfate, I've got 17 atoms. This is how many aluminium sulfates I have. I'm going to have to multiply this number by 17 to work out how many atoms I have in total. 351 by 10 to the 23. There's a lot of work there. Okay, that's not an easy question, and I know it was answered poorly when it came up 2 years ago, but that is ultimately how you will solve it. Even if you're not sure how to do the whole thing, try and work out the formula mass, try and get moles, because it's error carry forward the whole way down, and you will be able to get, if you got your formula mass wrong but you got moles with the wrong formula mass, you can get a mark for moles. And if you multiply your moles by this answer, by this Avogadro's constant, you'll get 2 marks. So don't lose hope, even if it's difficult. Try and do something with the numbers and you can pick up some marks along the way. Next few questions are on fuels. First one, general formula of an alkane. We learned that alkane is CnH2n plus 2. Alkanes are hydrocarbons. You'll get that from the mark scheme. They just, because they're compounds, or you can call them molecules, that contain carbon and hydrogen only. The word only there gets you your second mark. If they're part of a homologous series, what is true? So if they're part of the same homologous series, they have the same general formula. So alkanes are part of the same family, they've got the same general formula. Alkenes are part of the same family, they've got the same general formula. I want you to then use these 2 pictures to describe how you know butane and pentane are parts of the same family, and that they're different and that they're neighbors. Okay, so if we look at butane, if I add it up, I've got 4 carbons and I've got 10 hydrogens. And if I've got pentane, I've got 5 carbons and I've got 12 hydrogens. And as you go from butane to pentane, all you have to do is add a CH2. So I'm going from C4 to C5, so I'm adding a carbon. From H10 to H12, I'm adding 2 hydrogens. So I'm adding a CH2. Okay, so in your booklet it says successive members differ by a CH2, and we can see here these guys must be successive members because they're differing by just a CH2. Other thing that you can say is you can see that they're both alkanes. You actually get, oh, so I'm just looking at the marks from here, you get a mark for just saying they're both alkanes. Okay, I can spot they're alkanes because they're hydrocarbons with single bonds. You can say they both have the same general formula. General formula of alkanes being CnH2n plus 2. Alright, so any of these things are going to get you the marks. And then the last question, again this is maybe a little bit tricky. Butane, they tell you the formula of butane and they tell you you've got 100 grams and they want to know how much of that 100 grams is because of the carbon. So last week we looked at working out percentage by mass, and now we're going to do that again and we're going to use it. So if I look at butane, the formula mass is C4H10. So it's carbon, which has a mass of 12, they tell you down here. You've got 4 carbons, and then you've got hydrogen, which has got a mass of 1, and you've got 10 hydrogens. All right, so I've got 4 carbons, so 4 times 12, 10 hydrogens, 10 times 1. And if I add all that up, I see the total formula mass of butane is 58. But how much of that is from carbon? Well, carbon is 4 times 12. Carbon is 48. Out of the 58 of butane is because of carbon. And if I get that as a percentage, if I work out the percentage mass, I can see that 82.3% of butane is made up of carbon. Now, if you've got 100 grams of butane, how much is going to be carbon? You just need to get 82.3% of 100 grams. Because it's a percentage and you've already got 100, that's just going to work out as 82.3 grams. So if you work out the percentage by mass of carbon in butane, you can then get that percentage of the given mass and you'll have your answer. That one is a bit tricky and not a very common question.